Okay, guys, so this was a really good look at what is expected of you on the test. I'm going to give you for the test a blank unit circle that you are welcome to fill out for your own benefit, but it's not going to be graded as part of the test. Everything on the test is really kind of testing to see how much you know of that unit circle and how to apply it, but you will be given a blank unit circle that you can fill out if that helps you. Okay, so what I'm going to do is I'm going to take a look at this first page and just walk right through. I think these first three problems were the things that we struggle with the most in both classes. When you're told what the result of a trig function is, but you got to work backwards and figure out what that angle is. Okay, so for cosine theta equals square root of 3 over 2. When I'm thinking about this, and I'm going to try to draw something right here, I go, okay, cosine is referring to x. If the unit circle was like this, okay, square root of 3 over 2 is pretty far out. That's all the way here and all the way here. So it would have to be those two angles, which would be this one right here is 30 degrees, and this one right here would be 30 degrees short of 360, which is 330. Okay, and then if I've got to give those in radians, 30 degrees is pi over 6, and 330 degrees is 11 pi over 6. So how did I do that? I'm thinking, I remember that cosine connects with x. So I'm thinking, okay, x has to be positive, and it's got to be positive square root of 3 over 2, and that's where this is right here, okay? Next, let's see. We got this cotangent is square root of 3. Now, I'm going to tell you how I think about this. I know that tangent is equal to slope. And I also know that tangent is the reciprocal of cotangent. So that means that tangent, or the slope, has to be 1 over square root of 3, which is a pretty flat slope. It's not completely flat, but it's just not very steep at all. And so when I think about it, okay, so now I'm picturing the unit circle. I'm picturing what angles have a positive slope, but also a pretty flat slope, something like this, okay? Because if it's cotangent of square root of 3, then that means the tangent would be 1 over square root of 3, which, like I said, is approximately, a really rough approximation is about 1/2. So that's a pretty, gentle, pretty non-steep slope. And so that's when I picture these right here. And so again, this right here is 30 degrees. This angle over here is 210, all right? And so 30 degrees is pi over 6, and 210 is 7 pi over 6. And so those would be the two angles. That's how I do that. When I'm thinking about tangent, I think about slope. When I'm thinking about cotangent, I know it's the reciprocal of slope. All right? Let's see here. With cosecant, let's take a look at cosecant is equal to -2. Now, this is real simple. Cosecant, I know, is the reciprocal of sine. So if cosecant theta is equal to -2, then that means that sine theta is equal to -1/2. Okay, so again, picture the unit circle. All right? And I think, okay, y has got to be -1/2. So that's going to be like right here. And I'm going, what angles hit right there? Well, one way out here and one way back here. So this one right here has got to be 210, which is 7 pi over 6. And this one right here is 330, which is 11 pi over 6. A lot of repetition on this one, okay? So when I'm looking at a cosecant theta or secant theta, I'm just reminded that those are reciprocals of sine and cosine, okay? When I think about cotangent, I remember that's a reciprocal of tangent, which is slope. And so and when I'm thinking about cosine, I think about that's x, and sine is y. So hopefully that makes some sense. I know that those were the challenge, but I think if you've got your unit circle and you really think about what these are, it shouldn't be too bad. All right, let's take a look at these next 4. These are really simple. You just have to look at your unit circle or think through your unit circle and figure out, well, what happens? You know, cosine of pi over 3. Well, what is pi over 3? Pi over 3 is the same thing as 60 degrees. It's in that first quadrant. It's the steepest angle before you get to 90 degrees. And so cosine is the x value. So how far over? So what I'm picturing in my mind, I'm going, okay, first quadrant. All right. And so I know I went the shortest distance for, I went away from 0, but I went the first step away from 0. So that means the cosine would have to be 1/2 because the cosine is the x value. All right. For sine of 300, let's just try to continue this unit circle. Sine of 300, well, I know 300 is just into the fourth quadrant. It's only 30 degrees past straight down. And so sine is the y value. So I had to come way down on the y value. So that must be negative square root of 3 over 2. So that's what the sine of 300 is. The tangent of 240. Well, let's take a look at that. I'm going to draw the rest of it over here. Okay. The tangent of 240. Remember, tangent is slope. 240 is right here. So that's a very steep slope. Remember, you've got only a few options. You've got 1 over square root of 3. You've got a slope of 1, which is that 45 degrees. And you got a slope of square root of 3. Okay? And so this right here represents a slope of square root of 3. And it's this entire line, all right? It's not just the part that's in quadrant 1. It's also the part that's in quadrant 3, which is what this 240 is. So that would have to be square root of 3. Now, maybe you don't see it as slope, so let's think about it a different way. Maybe you think about it in terms of x and y, and you go, well, I know that that's y over x. Sure. So the x value is 1/2. The y value is square root of 3 over 2. So put your y over x, and you'll get square root of 3 over 2 over 1/2. The 2's cancel out, and you're left with just square root of 3. So either way, you should get square root of 3. And lastly, cosecant of 2 pi over 3. Well, pi over 3 is 60, so 2 pi over 3 is 120. So that's going to be just into the second quadrant right here. Okay? Now, cosecant is the reciprocal of sine. So I'm paying attention to what the y value is up at this point. The x value is negative 1/2. The y value is square root of 3 over 2 right there. And so then I need the y value, which is this one, and then I just got to take the reciprocal of it. So that's going to be 2 over the square root of 3. I think those are pretty simple. Again, the better grasp you have on the unit circle, the better off you're going to be. So if you want to go ahead and fill out that unit circle right at the beginning of the test and then work through, maybe that'll help. If you've got a pretty good grasp of it, then just do it how you think. All right, last problem we're going to do is this one right here in terms of unit circle stuff. So we got 300 degrees. 300 degrees is right here. We go, okay, so I'm looking and going, that's 300 degrees. All right, the reference angle, though, is right here. This part right here is the reference angle. So the reference angle is 60 degrees. So first of all, I'm going to say, well, reference angle is 60 degrees. Now let's convert each one of those to radians. 300 degrees is 5 pi over 3. And 60 degrees is just pi over 3. All right? Next, let's see here. Let's do the sine of 300 degrees. Okay, so sine of 300 degrees. Well, that's going to be that y value. We know that that point right there is 1/2 negative square root of 3 over 2. So sine of 300 is going to be that y value, which is negative square root of 3 over 2. Cosine of 300 is going to be that x value, 1/2. And tangent of 300 is just going to be this one over this one, which is going to give me negative square root of 3, because the 2's cancel out. All right. Now let's take a look at the pizza. All right, this is just a little bit of a quick refresher of how to do these pizza problems. And so before I try to answer questions 1 through 6, the first thing I have to do is I've got to just look at the basics. I got to remember that arc length, or crust in this case, is equal to radius times theta. And I need to know that surface area of a piece of pizza, or sector area, is 1/2 radius squared times theta, where both thetas have to be in radians, okay? And so what I'm going to do is I'm going to say, okay, for this first one, now this is the size, and then this is the number of slices, and then the cost. So the size, the number of slices, and the cost. The size, the number of slices, and then the cost. Okay, so if the size is 10, then the radius is 5. If there's 8 pieces, then I go theta has got to be 2 pi over 8, which is the same thing as pi over 4. Same thing with this one, because again, it has 8 pieces, so theta is going to be pi over 4. And this last one, it's got 10 pieces, so I say theta is going to be 2 pi over 10, which is going to be pi over 5. All right, so those are my thetas. My radius for this one is 5, my radius for this one is 6, and my radius for this one is 7. Now I have all the information. And remember, I've got right here, I've got the cost of one piece of pizza. I give it to you. You don't even have to figure that part out. So first I'm going to go, okay, well, let's figure out how long that crust is. That crust is going to be 5 times pi over 4. This crust is going to be 6 times pi over 4, which is the same thing as 3 pi over 2. And this one is going to be 7 times pi over 5. or 7 pi over 5. Okay? Now, we should get a rough decimal approximation so we know what we're talking about here. So we say 5 pi over 4 is about 3.93. So that's 3.93 inches. Okay, 3 pi over 2, much longer, is about 4.71. And 7 pi over 5 is about 4.4. Yeah, 4.40, about there. Okay, so I've done that. Now, let's go ahead and think about cost. Cost is always going to be that dollar amount per inch. Okay, always think about cost as being dollars per inch, or the other way is cost is dollars per square inch. And that'll just tell you what you have to put as a fraction. I take my dollars, this is my dollars up here, okay? And then this is my inches. So I just simply say, so the cost of this one is going to be 125 divided by, and I'm going to go back and use the original one right here, 5 pi over 4. Okay, and I can put that into the calculator, but I got to use a lot of parentheses. So I'm going to say 1.25 divided by, open a set of parentheses, and say 5 pi divided by 4, close a set of parentheses. I hit enter, and I get about, if I went to the nearest penny, I get 32 cents. So it's about 32 cents per inch of crust. Okay, next one. This one, the cost is going to be $1.50 divided by 3 pi over 2. So again, I'm going to put that into the calculator, say 1.50 divided by, open parentheses, 3 pi divided by 2, close the parentheses, hit enter, and I get the exact same price. Exact same price, okay? And again, I'm going to approximate it to 0.32. And then the last one, the cost is going to be equal to the cost of the piece of pizza, 140, divided by 7 pi over 5. So I say 140 divided by, open parentheses, 7 pi divided by 5, and I get the exact same price. That is absolutely hilarious. Okay, every time I got 0.31830988862 something, 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 something. Okay, how funny is that? That this just happened to work out the way we were talking about how the whole problem was, that it worked out exactly that way, that we got the exact same. And so when you did this problem, you might have thought, surely you must have done something wrong, but you didn't, okay? They all had different length crusts, but their crusts were proportional to the price of the pizza. That's incredible. So you say they all cost the same for crust. Now let's find surface area. Okay, so surface area is going to be 1/2 radius squared times theta. So we say 1/2 radius squared. For this one, radius squared is going to be 25 times theta pi over 4. Next one, area is going to be 1/2. Radius is 6, so we put 36 times pi over 4. And last one, the area is equal to 1/2. Theta for this one is 7. No. I got to go to radius. Radius is 7. Square that, and I get 49. And then theta is 7 pi over 5. Okay. And then let's find some approximation, or maybe before I find the approximation, let's just simplify that at least. Let's see, you'd have 25 pi over 8. Okay, for this next one, you would have, 36 pi over 8, which reduces to 36 pi over 8 would be 18 pi over 4, or 9 pi over 2. Okay, and then this one reduces to, let's see here, 343 pi over 10. Okay, so that's the area. Okay, we're going to find some decimal approximation. 25 pi divided by 8 is about 9.82 square inches per piece. 9 pi over 2 is about 14.14 square inches per piece, and 343 pi over 10 has got to be wrong. Why is that wrong? That seems like that's got to be wrong, because that's a huge piece. Okay, I'm sure you guys are laughing at me right now going, oh, he did something wrong. Oh, my goodness, of course. Okay, it's not 7 pi over 5. That was the length of the sector. That was not the theta. I was like, man, I must have something going on way wrong. So that 7's not supposed to be there. It's supposed to just be pi over 5. So that's going to change this drastically and make that 49 pi over 10. So I say 49 pi divided by 10. Sorry for the mistake, guys. So that's going to be 15.39 square inches. Okay, and so clearly here, the pieces get bigger in terms of surface area as you go with a larger pizza. And so now lastly, let's figure out cost. And so cost is going to be equal to, I got to go the cost of a piece of pizza, $1.25, over the surface area, 25 pi over 8. And so then the cost is going to be $1.50 over 9 pi over 2. And the cost is going to be equal to $1.40 over 49 pi over 10. Okay, so I say 125 divided by, open set of parentheses, 25 pi divided by 8. And this is now per square inch. I get about, about 13 cents. So it'd be 12.7 cents. So I'm going to round that up to 13 cents for the sake of time. And then 150 divided by, open set of parentheses, 9 pi divided by 2. And this time I get close to 11 cents. And then the last one, I got $1.40 divided by, open a set of parentheses, 49 pi over 10. And I get about 9 cents. Okay, so now we have all the information pretty quickly gotten, and we can go over the questions. It says, with which size pizza would I get the longest crust? Well, the longest crust was actually with the medium, okay? And so that would be medium right here. So number 1 is medium. Number 2, with which size pizza would I get the largest surface area of piece? Well, we got the biggest piece with the large pizza, okay? So number 2 is large. 3 is medium, 2 is large. Number 3, with which size pizza would I get the lowest price of crust in terms of dollars per inch? Well, the cheapest crust, it didn't make a difference. We always paid exactly the same, which was about 32 cents per inch. And so that you would say, not possible, or all the prices the same, or whatever. Number 4, with which size pizza would I get the highest piece? Well, again, not possible, all the same. Okay, number 5, with which size pizza would I get the lowest price of pizza in terms of dollars per square inch? And that came with the large, and that makes sense. The large is usually going to be the most bang for your buck. And number 6, with which size pizza would I get the highest price? And the highest price is going to be the small. Okay, and so for number 1, it was the medium, had the longest crust. Number 2, largest surface area was the large. Number 3 and 4 was all the same. Number 5, the lowest price was the large pizza. And number 6, the highest price was the small pizza. Okay, if you've got this, you should be ready to go, and let's take that test.